Section 4.4, homework assignment 4.4.9. Is there an association between party affiliation and gender? The accompanying data represent the gender and party affiliation of registered voters based on a random sample of 802 adults. Complete parts A through F. So the first thing we're going to do is we're going to construct a frequency marginal distribution using this table here. Okay, so first thing we want to do is we want to find the total amount in our table here. So if we add up all of these values here, we should get a total. The table total is 105 plus 115 plus 150 all the way to 802. So 802 is going to represent our table total. Okay, so that is the table total. All right, and so now what we want to do is we want to create a frequency marginal distribution. So here what we're going to do is we're going to add the 105 plus 150 plus 150, and that's going to give us our total here of 405. Okay, next we're going to take the next column. We're going to add 115 plus 103 plus 179. If we add those together, then that's going to give us 397. Okay, next what we're going to do is now we're going to add across using the rows. So we're going to add the 105 with 115. When we add those together, it gives us a total of 220. Okay, next we're going to take 150 plus 103, and that gives us 253. And then we're going to take 150 plus 179, which is going to give us 329. So the table total is going to have to equal 802. So when we add all these values up, it gives us 802. When we add these values up, it also gives us 802. So what we can do is, if we take a look, we have our values, 220, 253, 329, 405, and 397, and therefore that matches our results over here. Okay, now what we want to do is we want to construct a relative frequency marginal distribution. Okay, so how do we do that? Well, again, we're going to use our previous information to find a relative. So we're going to take a look at, again, these values, this 105, 150, okay, and we're going to add those up. So when we add those up, we get 405. So that means that we're taking the values of those three and we're adding them together, and then we're going to divide it by the table total. So 405, we add those together, divided by 802 gives us 0.5049. Okay, next, we're going to take the next column, 115, 103, 179. So when we add those together, we get 397, divided by the table total will give us 0.4905. Now we're going to take a look at the row. So we're going to add 105 with 115, and we know that that gives us 220. And then dividing it by the table total gives us 0.2743. Okay, next we have the following. We have 150 plus 103, which gives us 253. And then again, dividing it by the table total gives us 0.3154. And then last, we're taking the 150 plus 179, which gives us 329 from our previous table, divided by the table total, which gives us 0.4102. Okay, and so now what we're going to do is if we add those all up, it gives us 1. If we add the rows together, that gives us 1. And the last thing we want to do is we're going to round this to 3 decimal places so we can put in our answer. So this gives us 0.505. This gives us 0.491. This, we can round this to 0.274. This becomes 0.315. And this becomes 0.410. So let's go ahead and take a look. There is our values. So we were able to then create our relative frequency marginal distribution. Okay, now the next question says, what proportion of registered voters considers themselves to be independent? So we have our independent, And so we were going to look at this value here. Going across the row, we know it's going to be 0.410. So that means that 0.410 represents the voters that consider themselves to be independent. Okay, now what we're going to do is now we're going to create a conditional distribution of party affiliation by gender using this information. So let's go ahead and now let's take a look at creating a conditional distribution. Okay, so what are we going to do for that? Well, we're going to take our value, which is 105. So we're taking our 105 that represents females that are Republican, and then we're going to divide it by the column total, which is 405. So we're going to divide that by 405, and that gives us 0.25292. Okay, now let's take a look. How many female Democrat voters are there? We have 150, and we're dividing it by the column total of 405, which gives us 0.3703. And then how many independent voters we have? 150 divided by the column total of 405 to give us 0.3703. And then when we add that column together, we get a value of 1. Okay, next, now we're looking at the males. So how many males there are that are Republican? We have 115, and we're dividing it by the column total of males, which is 397, to give us 0.2896. The male Democrats is 103, so if we're going to take 103 and divide it by the column total of 397, gives us 0.2594. And then the independent males is 179 divided by the column total gives us 0.4508. And now let's go ahead and round each to 3 decimal places. So rounding this gives us 0.259. Rounding this gives us 0.370. And rounding this value is also 0.370. And then rounding this to 3 decimal places gives us 0.290. Rounding this to 3 decimal places is 0.259. And then rounding this to 3 decimal places is 0.451. And then let's take a look at our results here. So there is our conditional distribution. Okay, so now what we want to do is we want to now draw a bar graph of the conditional distribution. So what we're going to do is we're going to open up this data into StatCrunch. Okay, so here's our data, which is in StatCrunch. Okay, so now that we have our data, what we want to do is we're going to use what we found in the conditional distribution here. Okay, which is this one here. So what we're going to do is we're going to take female, put that first over here. So I'm copying these to male and female, which you can do on your own if you wanted to, or just type it in. So the first column that we're creating that's new is gender. Then we're going to create a column that represents Republican, another column that represents Democrat, and another column that represents independent. So all I'm doing is hitting Control button and then pasting it into the title there. Now, for the Republican for females, we have 0.259. So we're going to go ahead and put 0.259. Okay, for Democrat for females, it's 0.370. And for independent, it's 0.370. For male, it is 0.290. For Democrat, 0.259. And then for independent is 0.451. Okay, now what we're going to do is we're going to use those columns to generate our bar graph. So we're going to go to Graph and then go to Chart and select Columns. We want to make sure that our columns are going to be Republican, Democrat, and Independent. The row labels are going to be the column that we call Gender. And then we want the vertical bars that are split. And then we also want to make sure that we can see the horizontal lines to help us see what that looks like. Okay, and then we can type and say that the y-axis is going to represent the relative frequency. So let's go ahead and select Compute. So if we take a look at A, okay, this looks to be pretty close to that. So far we may include that this represents the graph for A. If we look for the graph of B, this doesn't match. If we look at graph for C, this also doesn't match. So therefore we're answering the graph to be A. Okay, now it says, is gender associated with party affiliation, and if so, how? And then choose the correct answer below. We would say yes, because gender is associated with party affiliation. Males are more likely to be independents and less likely to be Democrats in this bar graph.